Hello and welcome to statisticsmentor.com. I'm Phil. Look at these 9 problems. Can you solve them? They're all examples of where we are multiplying by powers. So what I'm going to do is give you the result first, the rule, and then we're going to work through all these. Now if you look at these and you understand how to work them out already, great. You don't need to watch this video. If you think you're stuck on any of them, just hang around. Right, here is the rule, and it reads as follows: x to the power of a times x to the power of b equals x to the power of a plus b. Now let's look more carefully at this rule. It's saying we take x is a number, and we take it to this number to the power of a, and we multiply the same number to another power. So first things to know, these two numbers must be the same for this to work. Another thing to note is that the x here can be whole numbers, they can be fractions, they can be negative, they can be positive. The a and b, they are numbers. They can be different numbers, or they can be the same number. And these numbers, the powers, can be whole numbers, just like x's can be whole numbers, fractions, negative, and positive. For any of you that have done more advanced math, we are ignoring the case of complex numbers. So we're talking about everyday numbers, what they call the real numbers. Although this works for complex numbers as well. But we don't have any examples with complex numbers in this tutorial. So now let's go and apply. Right, I'm going to now apply the rule and solve these things. Once you get the hang of the thing, I suggest that once you get the hang of what I'm doing, just try to solve it on your own first and then check your answers with what I do on the video. Who knows, I might make an error. Right, let's take it real slow at the start. 2 to the power 3, 2. This is shorthand for saying 2 to the power 3 times 2. And when there's nothing there, that means there's a 1 there. Alright, so you can see in this case the x is 2, a is 3, b is 1. So what does the rule say? 2 and add the powers. So that's 2 to the power of 4. Now use your calculator if you want a whole number, or you could do it in your head. That's 16. Okay, at this point I just want to look more carefully at what this is saying, and then you can see why the rule works. What this is saying, 2 to the 3, is 2 times 2 times 2. In other words, times the thing by itself that many number of times. And then this is times. And then this is saying 2 times by itself once. Alright? So then what you actually got, if you forget about the brackets, is 2 times 2 times 2 times 2. How many times are you multiplying 2 together? 1, 2, 3, 4 times. So it's 2 to the power of 4 is a shorthand way of saying it. Alright, not 4 times 2. This is different to saying 4 times 2. From this step to this step, you can do it in your head or use a calculator. I'm assuming that you know how to use the power function on your calculator. If you don't, I'm sure I can make a video on that as well. Just let me know. Right, the second one. 10 to the power of 3 times 10 to the power of 2. Well, there's nothing hard about this, so here x is 10. We add the powers. 3 plus 2 is 5. We can leave it like that, or you can see that this is going to be 1 with 3 zeros, 100,000. Next, we have an example where we've got a fraction. 8 to the half times 8. Nothing there, so it's a 1. So what does it say? works the same way, a and then add the powers. 1 plus a half is 1.5. Another way of writing 1.5 is 3 over 2. If you're not comfortable with that, just write 1.5. Plug it into your calculator, you get approximately 2.63 to 2 decimal places. Okay, next along the list is 3 to the power of minus 1, 3 to the minus 2. An example here where we have powers which are negative. Because remember we said that the powers can be positive and negative. There could be fractions as well. Same thing applies. We take x, which is 3, and then add these powers together. Minus 1 minus 2 is minus 3. Now, I don't know whether you're familiar with this other rule here, but a number to the power of minus something is the same as 1 over that number to the power of the positive value. So this is the same as saying 1 over 3 to the power of 3. In other words, if you've got a minus there, just turn it into a positive and do 1 over it. Okay, and that's 1 over 27, which you can plug in your calculator to get a if you want it in terms of decimal values. Okay, so that's done. Right, next we have the value x, which is equal to e. Now recall in math, e is a special number. It's approximately equal to 2.7183. Alright, so if you since that's a bit of a mouthful, just give it a symbol e, so that all e stands for is a particular number, and it's that number. So this thing still applies. So applying the rule here is e to the power, add these together, 0.25 plus 0.75, can you see that's equal to 1? So in other words, the answer is approximately 2.7183. Okay, and how about this one now? So we'll chuck in some fractions again. Using the same rule, a quarter plus 3/4, that's 4/4, which is 1. So in other words, it's the same as the answer's previous question. If you think about it though, there's no surprise, because a quarter in terms of decimals is the same as 0.25, 3/4 is the same as 0.75, which is what the previous question had asked you. Wow, okay, so we reached the last two. This one looks, if we look at it, looks a bit scary, doesn't it? Same thing applies though. Just think about the basics. What is x? X is 2, so just write that down. What is a? A is that, and b is that. So the rule just says, even though it looks like a scary kind of thing, a plus b. On a calculator, what we would do is calculate these two things first, and then do finally 2 to the power of the answer. So here the answer, using our calculator, comes to approximately this, to 1 decimal place. Okay, check to see if you can do that on your calculator. If you can't do that, give me a shout. Okay, and finally, wow, we've got a big queue of e's here. Power of 1, 2, 3, all the way to 10. Dot, dot, dot means that it continues. You can see the pattern 1, 2, 3, so 4, 5, 6, 7, 8, 9, 10. In other words, this, using the rule, comes to 1 plus 2 plus 3 plus all the way to 10. Do that on a calculator, that's e to the 55, which is a humongous number, so we can leave it like this. This last one is quite interesting because such thing appear in statistics, where we have e to the power of, and then we have some data values here. x1 is a data value, x2 is another data value, all the way to n observations, xn. Then the way to write where these actually numbers, but we'll give them just a symbol because they could be any number, so we just want some kind of very general form. And then what we can see from this is that we can tidy this up by using a summation operator. Well, hang on, let's not even introduce that scary thing. Let's just say that what this is simply, if we look at the example we've just gone previously, just sum of the x's, dot, dot, e to the xn. And then we can see using the summation operator, if we want to make this even shorter, sum from I if I can write it's too small, I equals 1 to n of xi. And this expression appears a fair bit when you are looking at statistics, and look out for it when we're dealing with exponential distribution, normal distribution. Okay, but if you're not doing stats, forget what I've just done here. Great, so I've just showed you how to multiply by powers. If you don't know how to do it on your calculator, if you want me to show you how, so just give me a shout.